Recently, a very important news were published about Hubble, Fermi, and a lot of news. The first news with us says, Hubble celebrates 34th anniversary with a look at the Little Dumbbell Nebula. M is classified as a planetary nebula, an expanding shell of glowing gases that were ejected from a dying red giant star. The star eventually collapses to an ultra-dense and hot white dwarf. A planetary nebula is unrelated to planets, but have that name because astronomers in the 1700s using low-power telescopes thought this type of object resembled a planet. M is composed of a ring, seen edge-on as the central bar structure, and two lobes on either opening of the ring. Before the star burned out, it ejected the ring of gas and dust. The ring was probably sculpted by the effects of the star that once had a binary companion star. This sloughed-off material created a thick disk of dust and gas along the plane of the companion's orbit. The hypothetical companion star isn't seen in the Hubble image, and so it could have been later swallowed by the central star. The disk would be forensic evidence for that stellar cannibalism. The primary star is collapsing to form a white dwarf. It is one of the hottest stellar remnants known at a scorching 250,000 degrees Fahrenheit, 24 times our sun's surface temperature. The sizzling white dwarf can be seen as a pinpoint in the center of the nebula. A star visible in projection beneath it is not part of the nebula. Pinched off by the disk, two lobes of hot gas are escaping from the top and bottom of the belt along the star's rotation axis that is perpendicular to the disk. They are being propelled by the hurricane-like outflow of material from the dying star tearing across space at 2 million miles per hour. That's fast enough to travel from Earth to the Moon in a little over 7 minutes. This torrential stellar wind is plowing into cooler, slower-moving gas that was ejected at an earlier stage in the star's life, when it was a red giant. Ferocious ultraviolet radiation from the super-hot star is causing the gases to glow. The red color is from nitrogen and blue is from oxygen. Given our solar system is 4.6 billion years old, the entire nebula is a flash in the pan by cosmological timekeeping. It will vanish in about 15,000 years. Since its launch in 1990, Hubble has made 1.6 million observations of over 53,000 astronomical objects. To date, the Mikulski Archive for Space Telescopes at the Space Telescope Science Institute in Baltimore, Maryland, holds 184 terabytes of processed data that is science-ready for astronomers around the world to use for research and analysis. Since 1990, 44,000 science papers have been published from Hubble observations. The Space Telescope is the most scientifically productive space astrophysics mission in NASA history. The demand for using Hubble is so high it is currently oversubscribed by a factor of 6 to 1. Most of Hubble's discoveries were not anticipated before launch, such as supermassive black holes, the atmospheres of exoplanets, gravitational lensing by dark matter, the presence of dark energy, and the abundance of planet formation among stars. Hubble will continue research in those domains and capitalize on its unique ultraviolet light capability on such topics as solar system phenomena, supernova outbursts, composition of exoplanet atmospheres, and dynamic emission from galaxies. And Hubble investigations continue to benefit from its long baseline of observations of solar system objects, stellar variable phenomena, and other exotic astrophysics of the cosmos. NASA's James Webb Space Telescope was designed to be meant to be complementary to Hubble and not a substitute. Future Hubble research also will take advantage of the opportunity for synergies with Webb, which observes the universe in infrared light. The combined wavelength coverage of the two space telescopes expands on groundbreaking research in such areas as protostellar disks, exoplanet composition, unusual supernova, cores of galaxies, and chemistry of the distant universe. The second news with us says, Explore the Universe with the First e-book from NASA's Fermi. To commemorate a milestone anniversary for NASA's Fermi spacecraft, the mission team has published an e-book called Our High Energy Universe, 15 Years with the Fermi Gamma Ray Space Telescope. Readers can download the e-book in PDF down the link in description. Launched on June 11, 2008, Fermi detects gamma rays, the highest energy form of light, from Earth's atmosphere to far-flung galaxies and cosmic phenomena in between. Its research has uncovered details on topics ranging from solar flares to star formation and the mysteries at the center of our Milky Way. Through images, fun facts, and launch day memories, the book tells Fermi's story from conceptualization to launch and recounts some of the mission's groundbreaking discoveries. By delving into high-energy astrophysics topics like gamma-ray bursts and blazars, readers can explore Fermi's universe and what questions remain open for investigation in its next chapter. Fermi was originally called the Gamma Ray Large Area Space Telescope but was renamed after Italian physicist Enrico Fermi in August 2008. Elizabeth Hayes, the mission's project scientist at NASA's Goddard Space Flight Center in Greenville, said, Enrico Fermi's science has been important for understanding the sources that the Fermi telescope sees. The gamma-ray sky is powered by particle acceleration mechanisms he theorized about. The satellite has two gamma-ray detectors, the Large Area Telescope and the Gamma-Ray Burst Monitor. The result of this carefully crafted duo is the most sensitive gamma-ray observatory in orbit, equipped to study the universe's highest energy phenomena near and far. By peering through Fermi's gamma-ray eyes, we can better understand our solar system. Within its first 8 years of operation, Fermi detected gamma-ray emissions from 40 solar flares, bursts of energy from the sun. Some even originated on the sun's far side, allowing scientists to analyze how charged particles fired by solar flares can arc from one side of the sun to produce gamma rays on the other. Fermi helps scientists understand black holes and other galaxies, too. Judith Rakusin, Fermi's deputy project scientist at Goddard, said, as a black hole forms, either from the death of a massive star or the collision of two neutron stars, it creates a brief flash of light called a gamma ray burst. Fermi detects about one burst a day and has helped revolutionize our understanding of these phenomena. Even after 15 years of accomplishments, however, many mysteries remain for Fermi to tackle. One of the telescope's ongoing objectives is to study the composition of dark matter, the mysterious substance that makes up about 25% of the universe. Because dark matter doesn't reflect, absorb, or emit light, scientists remain unsure of its composition. One popular theory suggests, though, that dark matter particles create gamma rays when they interact. If Fermi can spot this high energy signature, it might help scientists learn more about dark matter's makeup. If there's one thing Fermi has taught us, it's to expect the unexpected. Gamma ray research has yielded unprecedented breakthroughs in our understanding of the Milky Way's central black hole, our flaring sun, and merging neutron stars. As much as we anticipate the next gamma ray revelation, only time will tell what exactly Fermi has in store. Fermi is an astrophysics and particle physics partnership managed by Goddard. Fermi was developed in collaboration with the U.S. Department of Energy with important contributions from academic institutions and partners in France, Germany, Italy, Japan, Sweden, and the United States. And next news with us says, NASA astronaut to inspire Artemis generation in Boston. NASA astronaut Stephen Bowen, along with representatives from NASA and the International Space Station National Laboratory, will visit Boston on Wednesday, April 24 and Thursday, April 25 as part of the agency's Destination Station to highlight research opportunities aboard the station. Destination Station was created to educate the public and engage prospective researchers about the benefits, capabilities, and opportunities to use the space station. The space station has been continuously inhabited for more than 23 years, enabling more than 5,000 researchers to conduct more than 3,500 innovative experiments in the areas of biology and biotechnology, human health, space and physical science, and technology. Throughout the week, NASA and the ISS National Lab will meet with a variety of academic institutions, business incubators, and private sector companies with ties to the Boston community. During the visits, Bowen will provide perspectives on living and working in space. Bowen was the first submarine officer selected to be a NASA astronaut. He most recently served as commander of NASA's SpaceX Crew 6 mission to the station, where he was part of a 6-month research mission, Expedition 69. He is a veteran of 3 space shuttle flights to the station, including STS-126, STS-132, and STS-133. Bowen has logged a total of 227 days in space and conducted 10 extravehicular activities in his career. His 10 spacewalks make him one of 5 humans who have conducted that many spacewalks, and he is third on the all-time list for most cumulative spacewalking time. Bowen and the crews of Expedition 68 and 69 conducted more than 200 science experiments, including tissue chip research, bioprinting human cells and tissues in space, and studying antibodies in microgravity. Bowen is a Massachusetts native and earned his bachelor's degree from the United States Naval Academy in Annapolis, Maryland, and his master's degree from the Massachusetts Institute of Technology in Cambridge. Over the years, NASA's destination station has led to research collaborations aboard the orbiting laboratory with a variety of academic and commercial companies. Last News with Us says, pushing the limits of sub-kilowatt electric propulsion technology to enable planetary exploration and commercial mission concepts. NASA has developed an advanced propulsion technology to facilitate future planetary exploration missions using small spacecraft. Not only will this technology enable new types of planetary science missions, one of NASA's commercial partners is already preparing to use it for another purpose to extend the lifetimes of spacecraft that are already in orbit. Identifying the opportunity for industry to use this new technology not only advances NASA's goal of technology commercialization, it could potentially create a path for NASA to acquire this impulsion system must operate using low power and have high propellant throughput to enable the impulse required to execute these maneuvers. After many years of research and development, researchers at NASA Glenn Research Center have created a small spacecraft electric propulsion system to meet these needs, the NAS-HM sub-kilowatt Hall effect thruster. In addition, the successful commercialization of this new thruster will soon provide at least one such solution to enable the next generation of small spacecraft science missions requiring up to an amazing 8 km per second of Delta-V. This technical feat was accomplished by the miniaturization of many advanced high-power solar electric propulsion technologies developed over the last decade for applications such as the power and propulsion element of Gateway, humanity's first space station around the Moon. Small spacecraft using the NAS-HM electric propulsion technology will be able to independently maneuver from low Earth orbit to the Moon or even from a geosynchronous transfer orbit to Mars. This capability is especially remarkable because commercial launch opportunities to LEO and GTO have become routine, and the excess launch capacity of such missions is often sold at low cost to deploy secondary spacecraft. The ability to conduct missions that originate from these near-Earth orbits can greatly increase the cadence and lower the cost of lunar and Mars science missions. This propulsion capability will also increase the reach of secondary spacecraft, which have been historically limited to scientific targets that align with the primary mission's launch trajectory. This new technology will enable secondary missions to substantially deviate from the primary mission's trajectory, which will facilitate exploration of a wider range of scientific targets. In addition, these secondary spacecraft science missions would typically have only a short period of time to collect data during a high-speed flyby of a distant body. This greater propulsive capability will allow deceleration and orbital insertion at planetoids for long-term scientific study. Furthermore, small spacecraft outfitted with such significant propulsive capability will be better equipped to manage late-stage changes to the primary mission's launch trajectory. Such changes are frequently a top risk for small spacecraft science missions with limited onboard propulsive capability that depend on the initial launch trajectory to reach their science target. The mega constellations of small spacecraft now forming in low Earth orbits have made low-power Hall effect thrusters the most abundant electric propulsion system used in space today. These systems use propellant very efficiently, which allows for orbit insertion, orbiting, and many years of collision avoidance and rephasing. However, the cost-conscious design of these commercial electric propulsion systems has inevitably limited their lifetime capability to typically less than a few thousand hours of operation, and these systems can only process about 10% or less of a small spacecraft's initial mass and propellant. By contrast, planetary science missions benefiting from the NAS-HM electric propulsion system technology could operate for 15,000 hours and process over 30% of the small spacecraft's initial mass and propellant. This game-changing capability is well beyond the needs of most commercial LEO missions and comes at a cost premium that makes commercialization for such applications unlikely. Therefore, NASA sought and continues to seek partnerships with companies developing innovative commercial small spacecraft mission concepts with unusually large propellant throughput requirements. One partner that will soon use the licensed NASA electric propulsion technology in a commercial small spacecraft application is Space Logistics, a wholly owned subsidiary of Northrop Grumman. The Mission Extension Pod satellite servicing vehicle is equipped with a pair of Northrop Grumman NGHT-1 Hall effect thrusters whose design is based on the NAS-HM. The small spacecraft's large propulsive capability will allow it to reach geosynchronous Earth orbit, where it will be mounted on a far larger satellite. Once installed, the MEP will serve as a propulsion jetpack to extend the life of its host spacecraft for at least 6 years. Collaborating with S. Industry to find small spacecraft applications with propulsive requirements similar to future NASA planetary science missions not only supports you. S. Industry in remaining a global leader in commercial space systems but creates new commercial opportunities for NASA to acquire these important technologies as planetary missions require them. NASA continues to mature the electric propulsion technologies to expand the range of data and documentation available to you. S. Industry for the purpose of developing similarly advanced and highly capable low-power electric propulsion devices. Thank you very much for watching. Goodbye.